Container ring. The container/ring package is an implementation of the circular list data structure. Circular list is a ring data structure, where at the end the element will return to the initial element, head. If we illustrate it like this circular list data structure, we'll start by creating a file named container ring. Add the package main declaration and the main function. Creating a new ring with 4 elements. A new ring data structure is created with a capacity of 4 elements. This ring can hold 4 elements in a circular arrangement. However, initially, all the elements in the ring are empty. The ring serves as a circular buffer, allowing elements to be added and removed efficiently. Adding elements to the ring. Now let's create for loop. Inside the loop, we initialize the variable I with the value 1. Then, we evaluate the condition I equals 4, meaning the loop will continue as long as the value of I is less than or equal to 4. During each iteration of the loop, the value of the variable myRing is set to the value of I, and then the myRing variable is updated with the value of the next node. This allows us to traverse through a data structure called a ring, which is a data structure that stores elements in a circular order. This process repeats until I reaches the value of 4, at which point the loop stops. Iterating over the ring and printing its contents. We start by printing a message indicating that we are about to display the elements in the ring. Then, we use the do method on the myRing object, which presumably iterates over each element in the ring. Inside the do method, we define an anonymous function, a function without a name, that takes an argument x of type interface. This function is called for each element in the ring. Within the anonymous function, we simply print the value of x, which represents the current element in the ring. Now let's run code. As you can see, this is the result of the package ring.